Hello and welcome back to A-Level Math Mastery, where complex math becomes clear and success becomes simple. In today's episode, we are diving into the proofs of three important properties of absolute value. We'll start with property 3, the absolute value of a product. Then, we'll explore property 4, the absolute value of a quotient. And finally, we'll prove property 5, showing that the absolute value of a number is the same as the absolute value of its negative. Each proof will be broken down step by step, in clear, easy to understand language, so you can not only memorize the rules, but truly understand where they come from. Let's get started. Property 3. The absolute value of the product of two numbers is equal to the product of their absolute values. In other words, the absolute value of x multiplied by y is equal to the absolute value of x multiplied by the absolute value of y. We are trying to prove that the absolute value of x times y is the same as the absolute value of x multiplied by the absolute value of y. We begin by squaring both sides of the equation. This helps because squaring any number removes any negative sign, and we can eliminate the absolute value by squaring. So, we square the absolute value of x times y, and we get the square of the absolute value of x times y is equal to the square of x times y. Now, we expand the square of x times y. We know that when you square a product, it is the same as squaring each factor. So, x times y all squared is the same as x squared times y squared. So far, we have the square of the absolute value of x times y is equal to x squared times y squared. We also know that when you square a number, it becomes positive, just like taking the square of its absolute value. So, we can say x squared is the same as the square of the absolute value of x, and y squared is the same as the square of the absolute value of y. Therefore, we replace x squared with the square of the absolute value of x, and y squared with the square of the absolute value of y. So the equation becomes the square of the absolute value of x times y is equal to the square of the absolute value of x multiplied by the square of the absolute value of y. We now see that we are multiplying two squares, the square of the absolute value of x times the square of the absolute value of y. That's the same as taking the square of the product of the absolute value of x and the absolute value of y. So now we have the square of the absolute value of x times y is equal to the square of the product of the absolute value of x and the absolute value of y. Now, we take the square root of both sides of the equation. The square root of the absolute value of x times y is just the absolute value of x times y. The square root of the product of the absolute value of x and the absolute value of y is equal to plus or minus the product of the absolute value of x and the absolute value of y. So we now have the absolute value of x times y is equal to plus or minus the absolute value of x times the absolute value of y. Since we are dealing with absolute values which are never negative, we ignore the negative sign and take only the positive result. That gives us the final answer. The absolute value of x times y is equal to the absolute value of x multiplied by the absolute value of y. We have proven in full that the absolute value of a product is equal to the product of the absolute values. Property 4. The absolute value of a fraction is equal to the absolute value of the numerator divided by the absolute value of the denominator, provided the denominator is not 0. In other words, the absolute value of x divided by y is equal to the absolute value of x divided by the absolute value of y, as long as y is not equal to 0. We want to prove that the absolute value of a quotient is the same as the quotient of the absolute values. In plain terms, the absolute value of a fraction where a number x is divided by another number y is equal to the absolute value of x divided by the absolute value of y. This only works when y is not equal to 0. Because division by 0 is undefined in mathematics. Let's consider two real numbers x and y. Let's assume y is not equal to 0. We already know from earlier that when we multiply two numbers, the absolute value of the product is the product of the absolute values. That was property 3. We will apply a similar idea here, using division instead of multiplication. Let's look at the expression x divided by y. Now, take the absolute value of this expression. This gives us the absolute value of x divided by y. We know that absolute value tells us the distance of a number from 0, regardless of direction. So whether the result of x divided by y is positive or negative, its absolute value will be the same as the positive version of that result. Instead of calculating the result of x divided by y first and then taking the absolute value, we can take the absolute value of x and the absolute value of y first and then divide them. So we say the absolute value of x divided by y is equal to the absolute value of x divided by the absolute value of y. This is valid because the operation of absolute value is consistent with division, as long as we are not dividing by 0. Important reminder: this only works when y is not 0 because division by 0 is undefined. So we always include the condition y must not be equal to 0. Therefore, we have shown that the absolute value of x divided by y is equal to the absolute value of x divided by the absolute value of y, provided that y is not 0. Property 5. The absolute value of x is equal to the absolute value of negative x. In simple terms, if you take the absolute value of any number, it will be the same as the absolute value of its negative. This property tells us that it does not matter whether a number is positive or negative. The absolute value is always the same. That's because absolute value only cares about how far a number is from 0, not what direction it is in. So for any real number x, the absolute value of x is equal to the absolute value of negative x. Let's break it down using logic and the definition of absolute value. The absolute value of a number is its distance from 0 on the number line. It is always a non-negative number, meaning it's either 0 or positive. For example, the absolute value of 5 is 5. The absolute value of negative 5 is also 5. So, even though 5 and negative 5 are on opposite sides of 0, they are both exactly 5 units away from 0. So their absolute values are equal. Now, let x be any real number. If x is positive, then negative x is negative. And both numbers are the same distance away from 0. So their absolute values are equal. If x is negative, then negative x is positive. Again, they are the same distance from 0. If x is 0, then negative x is also 0. And the absolute value of 0 is 0. So in every case, we find that the absolute value of x is equal to the absolute value of negative x. This proves that no matter what number you choose, positive, negative, or 0, the absolute value of x will always be equal to the absolute value of negative x. And that wraps up our step-by-step proofs of properties 3, 4, and 5 of absolute value. We've seen how these properties are not just rules to follow, but logical results, built from what we already know about real numbers and distance on the number line. Understanding proofs like these will help you solve exam questions more confidently, and even explain concepts to others like a true math master. If this video helped you, don't forget to like, subscribe, and turn on the notification bell so you won't miss future lessons. In the next episode, we'll explore even deeper properties and begin applying absolute value in inequality proofs and real-world problems. Until then, keep practicing and keep mastering math. Right here at A-Level Math Mastery. See you in the next lesson.